This is week 7, which is the Cisco chapter on point-to-point connection, PPP. Here we just introduce more information than the book chapter, okay? But many of the information is repeated. So here in this chapter, we learned about this is your network in the United States between the carrier and the home premises. We have the demarcation point, okay? This is called demarcation, okay? Demarcation is the point where your network interfaces with a network that is owned by another organization. يعني like حدود. هاي معناها demarcation يعني التفصل. This owned by telecom company, and this is by my company. Okay. Alaikum salam. So it is interface between CPE, customer premises equipment, and network service provider equipment. Okay. A point in the network where the responsibility of the service provider ends. So these are all definitions for demarcation point. You see, in the US, it is up to this point. In the world, it is at this point. So in the US, the owner has more power. DTE and DCE. Each one link will have a DCE and DTE. DTE is data terminating equipment. It's commonly a CPE, generally a router. Yani a router is a DTE device, or a terminal or computer can be a DTE device, printer or fax. The DCE, like the modem or the CSU, DSU, it is a device to convert the user data from the DTE into a form acceptable to the one service provider transmission link. Okay. The signal is received at the remote DCE, which decodes the signal back into a sequence of bits. The remote DCE then signals this sequence to the remote DTE. So if you can see, okay, if you can see here, we have a network, we have DCE, we have DTE. DCE, DTE. These are the cables. These are the smart serial connectors. Okay, this is a DTE cable here. And this is a DCE cable. You see the DTE, it has pins. DCE has holes. Okay. Data is encapsulated into frames before crossing the WAN link. We already know that in the data link layer, in the network access layer, we use frames, and the WAN link will have frames, and appropriate layer 2 encapsulation type must be configured. These are some examples of layer 2 encapsulations. For lease line, we have examples like PPP, HDLC, and SLIP. For circuit switched, these are the sample protocols, HDLC, PPP, and SLIP. For packet switched, we have X.25. This is an old technology. We have frame relay and we have ATM. Now each one of them, this is the definition. Please spend 2 minutes reading the definitions. We already talked about them in the book chapter. We said that X25 is an older one now. It's not used. It used to be used in the banks, but now nobody is using it. It's been replaced. HDLC is high-level data link control. It is a group protocols or rules for transmitting data between network points or nodes. SLIP is the result of the integration of modern protocols prior to the suite of TCP/IP protocol, but now nobody is using it. SLIP is the old technology. PPP, it is a much more developed protocol than SLIP, and that's why it replaced it. SLIP was there before we started using TCP/IP. Frame relay and ATM are the most common packet switching technologies. Legacy is X.25. HDLC is by bit oriented. It is synchronous data link layer protocols. It is developed by ISO, so anyone can use it. It's a standard. Okay? But Cisco, they developed their own HDLC. It's called CHDLC. The last line here. So please don't forget CHDLC only for Cisco devices. HDLC alone can be used by any device. Okay. CHDLC is proprietary of Cisco. How do I do the encapsulation? First, I will call the interface. Then I will give the encapsulation command. As simple as that. PPP. PPP contains three main components. HDLC for encapsulating datagrams over point-to-point links. Extensible Link Control Protocol, LCP, to establish, configure, and test the data link connection. And the NCPs, which is Network Control Protocols, to establish and configure different network layer protocols. Okay, so these are the three main components of PPP: HDLC, LCP, and NCP. By the way, HDLC is the default encapsulation on a serial link. They might ask you, yes, what are the three main components of of PPP? Yes. Short answer, yeah. PPP is not proprietary. PPP includes many features not available in HDLC, such as link quality management. It monitors the quality of the link. If too many errors are detected, PPP takes down the link automatically. There are two types of authentication on PPP: PAP and CHAP. CHAP is more secure than PAP. Please pay attention to this, because CHAP provides three-way handshake. The passwords are encrypted. With PAP, the passwords are clear text. So CHAP is more secure. CHAP stands for Challenge Handshake Authentication Protocol. PAP is Password Authentication Protocol. So this is how the architecture is layered in PPP. LCP sets up the PPP connection with its parameters. NCP handles higher layer protocol configurations. And then at the end, the LCP will terminate the connection when you are done. Okay. LCP provides automatic configuration of the interfaces at each end, such as handling varying limit on packet size, detecting common misconfiguration errors, terminating the link, determining when a link is functioning properly or when it is failing. This is all done by LCP. There are optional functions for your PPP, which is the authentication. You can choose your authentication PAP or CHAP, and I just told you now CHAP is more secure because it provides three-way handshake. It is the passwords are encrypted, okay, and also the challenge is happening always. Yani it's not only one-time authentication. No, it is continuous. Compression also can be done on the PPP. You can use either stacker or predictor for compression. Also, multi-links can be used to combine channels to utilize the bandwidth. Yani I can use multi-link to combine two or more channels. This is all in PPP. In the lab, we will not do stacker or predictor or multi-link, but we will do PAP and CHAP. Okay? Any questions? To configure the PPP, you need to do the authentication. Either you do PAP or CHAP. You need to choose your compression, whether it is stacker or predictor. This is the basic configuration of PPP. By the way, it's very simple. First, you will go to the router. You will call the interface, give it an IP address, configure or decide your encapsulation to be PPP. Same thing on the other side. Okay? Not done yet. If you want to check your PPP configuration, you need to put the command show IP or show interface serial S0/0/0. We are doing the serial because we are on a one link. Frame relay is on a one link. I don't use frame relay here. Frame relay is for one. Okay. This is the PAP. PAP is only two-way handshake. So computer one is sending its username and password, and computer two, it will compare it to its database. If it has the password, it will accept. That's it, very simple. And the password is sent in clear text, so it's not good. This is the CHAP. It's a three-way handshake. A challenge is done by the central router, and it's using hash. The password is hashed. Okay. We are going to do this in the lab, inshallah. Configuration. This is the syntax template. PPP authentication, whether it's CHAP or PAP. Okay, that's the command. And these are the options, CHAP or PAP, or you can have CHAP and PAP, PAP and CHAP. For the lab, we will use PAP and CHAP, each alone, okay?
Using both will make it more secure? Or makes it more complicated?
No, here, look here, it will enable CHAP and PAP, but it will do PAP authentication before CHAP. If you do CHAP PAP, it will do CHAP first, then PAP. Yeah, of course, a little bit more of security. This is the configuration on each router. So you see here, you are on router 1. You are giving the command encapsulation PPP, PPP authentication PAP, and then you put the username and passwords. Okay. Same thing on router 2. The CHAP authentication is simpler. You put the R1 and then you put R2 and password, and you use the command authentication CHAP. Let us do the lab. Any questions, by the way, before on this chapter?